look up at the night sky. By 2050, that quiet black space above you will be more like rush hour in a megacity. Thousands of satellites, dead rocket stages, and fragments of old missions all racing around Earth at tens of thousands of kilometers per hour. Tonight, I want to show you how we turned orbit into a traffic jam, what happens if it all goes wrong, and why one really bad day in space could feel like a global internet blackout on Earth. This isn't science fiction. This is the roadmap we're actually following. First, how did we get here? For decades, space was slow. A few countries, a few satellites, huge gaps between them. Then launch costs dropped. Private companies entered the game. We started putting up satellites for communication, navigation, weather, agriculture, surveillance, global internet. And we almost never brought them back down. Every rocket leaves behind stages. Every failed mission leaves junk. Every collision creates clouds of shrapnel. We didn't build a clean, minimal space network. We built something closer to a junkyard that still has to work 24/7 for the entire planet. On a highway, a traffic jam is annoying. In orbit, a traffic jam is lethal. Two satellites can pass within a few hundred meters of each other. If they collide, they don't just bump and stop. They shatter. Each impact sends out hundreds or thousands of fragments. Every one of those fragments is a tiny bullet that keeps orbiting Earth for years or decades. This is the nightmare called a Kessler cascade. One collision triggers another, then another, until a whole orbit becomes too dangerous to use. Imagine losing GPS, weather forecasts, global banking links, container tracking, television, and large parts of the internet. Not because a cable broke, but because we filled the sky with unmanageable debris. So, what does a bad day in space actually look like? Picture this. A dead satellite in a crowded orbit can't maneuver. A small fragment hits it. Nobody even sees the impact. Minutes later, radar stations notice a cloud of new objects spreading like shrapnel. Some fragments hit another old satellite. That creates more fragments on slightly different paths. Now active satellites have to dodge again and again. Each evasive maneuver burns fuel and shortens their working life. Ground control centers are watching screens fill with red warnings. GPS glitches in certain regions. Some flights change routes. Stock markets complain about latency issues. News anchors talk about temporary technical difficulties. Most people on Earth never hear the full story. But in the background, we just lost a piece of orbit for years to come. The good news, we're not completely asleep at the wheel. Companies and space agencies are testing ideas for orbital tow trucks spacecraft that can grab junk and drag it down into the atmosphere to burn up. Others design satellites with built-in self-destruct plans, drag sails that make them re-enter faster, or engines that push them into a graveyard orbit when their mission ends. There are proposals for real space traffic control, mandatory tracking, right-of-way rules, even fines for leaving junk. The bad news, all of this costs money, time, and international cooperation. And right now, we're much better at launching new satellites than cleaning up the old ones. So where does that leave us? By 2050, space will be more crowded, more useful, and more fragile than ever. The same orbit that gives you maps, messages, and memes could, if we mismanage it, turn into a minefield. The future of space isn't just about new rockets or futuristic starships. It's about whether we treat orbit like an infinite empty sky, or like a shared city with rules, traffic lights, and yes, garbage collection. If you want more deep dives into the strange future we're building above our own heads, hit subscribe and tell me in the comments, would you trust humanity to run a safe space traffic system? Transmission ends. For now.